Hello and welcome to this webinar together with our partner AVSystem. So today we'll be talking about getting started with AVSystem Coiote and nRF Cloud location services. So AVSystem Coiote, they provide world-class device management, and nRF Cloud, there we have world-class location services. So just a quick intro. My name is Björn Kvole. I'm a product marketing engineer at Nordic Semiconductor. And with me, I have Marcin and Seppo. Marcin, do you want to say a few words?
Hello, I'm Marcin. I'm working for AVSystem as the product director responsible for IoT. Seppo.
Hello, my name is Seppo Takalo. I'm a senior R&D engineer here at Nordic Semiconductor and leading a small team of engineers with focus on nRF Connect SDK and mainly using nRF 9160.
Okay,
Thanks.
Great, thank you. So just for me, just some quick practicalities before we get started. So the duration will be approximately 60 minutes. Questions are encouraged, but please type the questions in the top of the right sidebar. So I see a few of you have sent some messages in the chat. The chat is not where you should ask your questions. You should ask the questions in the top right corner of your screen. All of the questions are anonymous. Try to keep them relevant to the topic, and we'll answer towards the end during the Q&A session. Like I said, the chat, it's not anonymous and should not be used for questions. If you have any more questions at the end after the webinar, feel free to go to Nordic Dev Zone for Nordic-related questions, or you can go to either send an email to iot@avsystem.com, or you can click on the link there to go to the AVSystem Discord channel to get support there. And last but not least, a recording of the webinar will be available together with the presentation at webinars.nordicsemi.com in a day or so. So just a quick abstract. So I'll go through lightweight machine-to-machine for device-to-cloud connectivity, and then I'll hand it over to Marcin for an introduction to AVSystem. Next, I'll talk quickly about Nordic and AVSystem benefits before I'll hand it over to Seppo for the demo itself. So connecting the nRF 9160 DK to AVSystem Coiote, and then connecting to nRF Cloud location services from there. So without further ado, we can get started. Okay, great. Then I'll get started with an introduction to lightweight machine-to-machine for device-to-cloud connectivity. So first off, a typical customer use case. Let's say you need to build an asset tracker or some kind of remote monitoring solution. You have your cellular IoT device with nRF 9160, a few different sensors. You're connected via either LTM or narrowband IoT to the cloud. And this is normally where the first questions start to pop up. So of course, you need to make the decision, which cloud do you want to use? How do you want to send the data? How much data are you going to send? Which protocol do you want to use? UDP or TCP based? Depending on which cloud you use, they will have a set of supported protocols, so that might constrain you a bit. Do you need to support firmware over-the-air updates, fleet management? Do you need location services, and how are you going to get the location services from nRF Cloud? So to help you answer some of these questions, we do have a best practices for cellular IoT development white paper, and we also have more information on our website. I can just quickly show you this. So here is our cellular IoT webpage, and here we have information on certification, a bit more information on the SIP, the best practices guide. We also have a webinar that goes into more details on the best practices guide. So let's move on to some of the main building blocks. So of course, for the device itself, that's quite simple. You would choose the nRF 9160 system and package. It supports LTM, narrowband IoT, and GNSS. So that's GPS plus QZSS. Ultra low power. If you click on this link, you get to our online power profiler where you can set up different parameters based on your use case, and then see the estimated power consumption. This is based on testing we've done with a base station tester. Very small form factor, 10 by 16 millimeters. The SIP itself is pre-certified. It also has multiband for global coverage. The great thing about the SIP, it does enable single chip solutions with a high level of integration. So if we take a quick look, you have on the application processor side, you have an ARM Cortex M33. And then on the modem side, we have a separate modem processor with LTM, narrowband IoT, and GNSS support. And inside the SIP itself, you also have power management, passives, and crystals, and the RF front end. So all you really need to add as a customer is a battery, one or multiple sensors, SIM card. We do also support embedded SIM, LT antenna, and if you need GNSS, a GNSS antenna. Moving on to the nRF Connect SDK. This is our nRF SDK that supports the nRF 9160 SIP. Very easy to use and flexible. So as you can see from the diagram, the layers in black are pre-compiled, pre-certified. Then you have the blue, which is Nordic source code, and the purple is open source source code. So on the modem core, this is where you have everything from the radio PHY up to TLS, DTLS security. The integration, the communication between the app core and the modem core is done via the modem library and using IPC shared memory. Moving on to the app core, you have all of the main protocols are supported, and we have a bunch of different libraries too for AT commands, GPS driver, DFU, etc. And of course, your application then runs on the top. And the great thing is we do support all clouds, and we do have a lot of different examples and tools to help you get started. So on the nRF Cloud Location Services side, this is offered as a part of nRF Cloud, and we do have a unique offering to help customers who need enhanced location solutions. So oftentimes that is, let's say, a more power efficient solution than regular GPS. So if you need a very precise location, let's say a few meters, we do have assisted and predictive GPS, which offers a quicker time to first fix compared to standard GPS. On the cell-based side, we also have single cell and multi-cell. This uses less power than GPS, but the trade-off is lower accuracy. So for single cell, up to 1,000 meters accuracy, for multi-cell, up to 300 meters. And we also have Wi-Fi location services. And again, seamless integration with the nRF 9160. And the main idea is, getting a very accurate and power efficient ways of getting location data. And the great thing is you can use it in one of two ways, either device to cloud. So the nRF 9160 communicates directly to nRF Cloud, or you can use cloud to cloud, where the nRF 9160 communicates to third-party cloud, let's say AVSystem Coiote, for example, and then the third-party cloud connects to nRF Cloud Location Services, often via a REST API. More information on our webpage. So that's here, a bit more info. And if you go to nRF Cloud, you can also see the pricing. So we have Developer, Pro, and Enterprise plan. Now I'll hand it over to Marcin for an introduction to AVSystem.
Thanks, Björn. So now AVSystem goes, and we would like to start with a very brief introduction of AVSystem. Who are we? Where do we come from? We are operating on the market since 2006, so this year it's 16 years of experience, and we originally come from the telecommunication sector. We have been building solutions for device management of telco devices, such as set-top boxes, gateways, and so on. And we have been quite successful in this vertical with 80 million managed devices these days across 60 countries. However, for the last couple of years, we have focused a lot on the Internet of Things and providing device management solutions as well, in the IoT space. What makes us different from the other solutions in this area is that we look into these aspects of affordability, security, and energy efficiency. And our IoT mission statement talks about attentive coexistence of human, environment, and technology. And we argue that these aspects of affordability, security, and energy efficiency are the key factors in order to achieve this situation, this state. Our IoT product portfolio consists of two product items. The first one is ANJ, our lightweight machine-to-machine client SDK. This is an agent that is installed on the devices, and it is responsible for talking with sensors and actuators on the device. It collects, makes sure that data collected by the sensors are reliably sent to the server, and it also is accepting commands sent to the actuators from the server, and is also supervising the over-the-air update process. On the other side, there is a Coiote IoT device management platform. This is the cloud part or a server part if you are not deploying in the cloud. But cloud is our preferred product. And this is the component that is accepting communication from the devices, providing device management functionalities, and is also acting as a communication hub for devices where the data sent from the devices are dispatched by this platform to third-party solutions like application enablement platforms. So ANJ and Coiote together, what is the value for customers? And when you are providing an IoT solution, you are appreciated by your customers, you are paid by your customers for the actual business value that you bring. So for example, if you are providing solution in the waste management space, your customers pay you for optimizing their daily operations that allows them to save money. And in the same time, if you want to build a robust solution, there are plenty of things that you need to do it yourself internally, for which your customer will not appreciate you. They will just take it for granted. These are, for example, reliable data collection, reliable connectivity, security, over-the-air updates, mechanism for device monitoring, mechanisms for device provisioning, and so on. In this picture on the right, these are all these things that are, below the surface of the iceberg. And we, in ANJ and Coiote, are providing these underwater parts that help facilitate development of your solution. So we are a solution that takes care of this and let you focus on your actual business case. So in other words, to put it in this user story type of language, we can say as a user, I want to focus on building my application, building what I'm paid for, developing my business. And I don't want to take care of all these things that my customers take for granted, like device provisioning mechanisms and so on. And further on, if we take into account our focus on device sustainability, energy efficiency, and so on, our solution is very much optimized for constrained devices, so we want to focus on saving device battery. So we try to manage the device in such a way that we are avoiding opening many connections to different cloud endpoints, and also send as little data as possible, but in such a way that will be enough for providing sufficient information about the device state. The second problem is related to this aspect that if you are sending more you are also paying more because the amount that you pay for your traffic is proportional to the amount of data that you are sending. But also sending is expensive in terms of the battery life, because the more you send, the shorter is your battery lifetime. So we try to optimize in this area. So how do we do it? And our foundation is lightweight machine-to-machine protocol. So these two products are built on top of this protocol. And lightweight machine-to-machine has been built initially with the focus on the constrained devices. However, it can also be applied to normal devices. There are no limits here. And because it has been built with this constrained devices in mind, then it puts a lot of focus on low resource consumption, which lowers the operational expenses. The most important thing about lightweight machine-to-machine is a well-defined data model. This data model is describing sensors, actuators, over-the-air update processes, and so on. And as such, if you are a device maker, you can, instead of reinventing the wheel again and thinking how to describe a sensor, particular type of sensor, you could just take a look if there is, a catalog of objects, and if you could reuse an existing model for it. The model, in order, to be published and available publicly, needs to go through the review process by the community. So if you are using the public object, you get some sort of, confidence that this has been proposed by someone, so somebody has thought about this problem, how to model it correctly. It has been peer-reviewed and accepted. So edge cases, bugs are hopefully already identified, and this is something that should let you develop your solution quicker without avoiding these usual hiccups or like teething problems in the early phase of development. Security, also a very important aspect of lightweight machine-to-machine. DTLS, so security on the transport level, is part of the protocol specification, together with OSCORE. And this is an application layer protocol that provides end-to-end security between the device and the server. We talk a lot about this, standardized based design. So over-the-air update messaging semantics is defined, semantics for device management, and as well for data collection. So all of these things are multiplexed together on one interface as a way to avoid the necessity of opening multiple connections. I mentioned this low resource consumption. This results in longer battery lifetime for devices that are using lightweight machine-to-machine, producing less waste. So we can be talking about sustainable solutions. And finally, since lightweight machine-to-machine can be run across different transport protocols, also in non-IP networks, this nice abstraction that it creates can provide a single pane of glass if you are having different classes of devices using different types of transport. Now, going a little bit more into technical details, on the left we see a stack of lightweight machine-to-machine protocol, and the heart is here on this lightweight machine-to-machine layer. The well-defined data model is part of this. The objects, sensors, actuators, over-the-air updates process, but also the semantics of messaging. So what is following what? The difference between using a raw CoAP, MQTT or HTTP is that you, as a device maker or solution provider, need to write your own message semantics. So you need to define some sort of your own protocol on top of CoAP or MQTT or HTTP. With lightweight machine-to-machine, you get these aspects of modeled sensors, actuators, over-the-air update processes, device management command mechanisms for device collection, device provisioning functionalities as well, all of them defined by the messaging semantics, by the protocol standard, so you get it all working out of the box. Then, in terms of efficiency, lightweight machine-to-machine is based on existing very efficient encoding mechanisms like CNML, JSON, CNML, CBOR, and is also defining its own lightweight machine-to-machine CBOR encoding protocol to further improve encoding characteristics of the messages that are being sent. Going down with the protocol stack, the default the default or like the recommended protocol that is run under lightweight machine-to-machine is CoAP. This is the protocol designed for the constrained networks as lightweight machine-to-machine. And CoAP is again recommended to be run over UDP and DTLS stack. So UDP is lighter than TCP, so this is very much well in line with this efficiency of communication, shorter messages with UDP than for TCP, and also avoiding the expensive handshakes that are required for establishment of a connection. For some reason, if UDP and DTLS is not possible in your network, that's also a possibility. You could run it over TCP and TLS. You are losing some aspects, of this communication efficiency. But if it's a must, then it's a must. And then IP below it, as usual. CoAP also allows to be run or lightweight machine-to-machine in non-IP networks as well. For example, cellular, IoT, LoRa, SMSs. And in this type of deployment, the raw CoAP packets are being pushed directly on the wire. This is another way of communication optimization. You are avoiding the overhead with DTLS, UDP, IP layer, so it can be quite a significant amount of bytes on each packet. However, there is this dependence on the underlying physical infrastructure. Since version of 1.2 of lightweight machine-to-machine, it is also possible to run it in parallel to CoAP with MQTT or HTTP. So different types of bindings are also possible. If you don't want to go for CoAP, that's also possible. But generally, what I want you to take from this slide is that lightweight machine-to-machine is a protocol on top of this MQTT CoAP layer, and it provides the whole messaging semantics together with the data model. If you are interested to learn more about lightweight machine-to-machine, we invite you to visit our website with the crash course for more information about it. So, where do we sit in this whole IoT ecosystem as a solution provider in this space? We originally, are coming from this MNO, mobile network operator, also virtual operator space. So we are responsible for certification of lightweight machine-to-machine devices in AT&T. We are collaborating with Vodafone, Truphone, SoftBank, and many other telco operators. We are also present in alliances, trying, to shape the standardization of IoT in the future. Member of the OMA spec work, the standardization body behind lightweight machine-to-machine. Member of UCFI. This is another standardization body that is promoting the idea of smart city based on the IPSO objects, and these IPSO objects are based on this well-defined data model provided by lightweight machine-to-machine. And also member of the Zephyr Foundation, where we are also looking into mechanisms to improve lightweight machine-to-machine and adoption on the Zephyr market, on the Zephyr devices. In terms of other subjects, we are collaborating with OEMs, especially with the focus on the utilities, asset tracking, mHealth, and agriculture market. In terms of technologies that we are using at the moment, we are mostly focused on NB-IoT and LTE-M, cellular network technologies. This is because we see a lot of traction on these networks. However, we are network agnostics, but since we focus a lot on this optimization, so we are working hard in order to make our solution optimized within these networks at the moment. We look a lot into these aspects of security, so secure elements, hardware security, IoT safe, if you want your SIM card to be your secure element. And also lots of emerging technologies. Emerging technologies for us, these are technologies that are already being, adopted by some other companies, but we are also looking how we can incorporate them into our offering. So, AVSystem, in the end, is your partner throughout the whole journey of device creation until the phase of solution maintenance. In the very first prototype phase, what we are offering pre-integrated ANGI lightweight machine-to-machine SDK with the Nordic thingy or Nordic nRF 9160 development kit and a free version of the Coiote platform. This Coiote platform, this developer version, free version of Coiote platform is restricted in terms of the features, but this is the set of features that is sufficient for you to prototype your device and play with it. And we are also providing a bridge to nRF Cloud, AWS, and Microsoft Azure clouds. Now, once you prototype your device, you are happy with it, you are thinking about starting the mass production, you are going to the manufacturing phase. So in this manufacturing phase, we can support you in terms of the security, especially in terms of device provisioning mechanism. We are providing support for EST, enrollment over secure transport, with bindings for the third party, certificate authorities, IoT safe, and the whole ecosystem of our partners in this step. Once you are producing, you are manufacturing your devices, you have provisioned them, then they are ready, to be deployed to production. So we are thinking about, slowly ramping up first from, tens, hundreds of devices up to thousands, tens of thousands, hopefully hundreds of thousands. So as part of this, we are offering the Coiote platform with the scalable deployment model. Our recommendation is to use the cloud, as mentioned earlier, since this is the most flexible and gives you access to the most of the features. We have very well optimized firmware update process, pre-integrated, everything working out of the box, and the platform is optimized for this LP1 network, so NB-IoT LTE-M, in order to extend or make sure that the battery lifetimes are really long. And then finally, you are getting into this maintenance phase where you need to keep your solution running. So there is this basic support. You can think about 24/7 SLAs, but we also have a dedicated customer success team that helps you grow your solution. So with running the solution, there are questions arising, new problems are being discovered, your requirements are being created, and our customer success team is responsible for identifying these requirements, working with you side by side in a way, to identify what we can do together in order to help you grow and help us grow. And we believe, this is like a never-ending story, since, there are going to be new classes of devices, new requirements. So you might be, running your own deployment and then thinking about, designing a new class of devices and, repeating this whole journey once again and once again. So this was it, a little about AVSystem, and now back to Björn.
Okay, thanks for that, Marcin. Just a quick slide from me on Nordic plus AVSystem benefits. So as you can see here, you have the nRF 9160 with the LwM2M client based on top of CoAP UDP using either LTM or narrowband IoT. In this scenario, you're connecting to AVSystem lightweight machine-to-machine server, the Coiote IoT device management platform, and LwM2M is used for data, device management, that could include firmware over-the-air updates, etc., and also nRF Cloud location services. And then it's AVSystem that communicates to nRF Cloud location services and also your own customer cloud. So that can be AWS, Azure based. So the great thing is AVSystem is a solution partner, and they do offer great LwM2M solutions as well as device management. And there is full integration of the nRF 9160 with AVSystem Coiote for data, device management, and location services. On the client side, you can either use the Zephyr stack, so that's included in nRF Connect SDK, and that does have Coiote IoT support, but you can also use the AVSystem OnJ client, which has been ported to the nRF 9160. We do have out-of-the-box integration with nRF Cloud location services and free development up to 10 devices. More information on the partner page website for getting started and examples. So yeah, that's it for me. Now I'll hand it over to Seppo for the demo.
I'm going to demonstrate how to integrate the AVSystem Coiote service and the nRF Cloud location services, and then connect my nRF 9160 DK board into the AVSystem. So first we need to do some preparation, and I'm assuming that the developers don't have account to either of the systems. So I'm going to show how to get the free developer account created for both of these and then enable the integration. So first we will start from the AVSystem website. So on the top you find the products and Coiote IoT device management, and if you scroll down there is now free developer account available. So I will sign up into this. So this will lead me to the Coiote login page, but I need the new account, so I click the sign up. Then I enter my email, generate the password, agree the terms and condition, and click sign up. Then it will tell me that there's a new email coming. So I will go into my email inbox, and this is what I'm getting. So there's a button or link, and it will lead me to my newly created AVSystem account with the hello page telling me to add my first device. Actually, I want to do the integration first. So after clicking the add my first device, there's a selections, but I want to skip this. So I click the there's a back button here. So I'm getting back to the normal inventory of the Coiote, and this should be empty because this is just a completely new account. Then the next step is that I will create the nRF cloud account. So I will go into the nrfcloud.com. There's also, if you check, there's a free developer account available. So this is what I'm using for now. Click the create an account, enter your email, click generate password, and click agree to terms and create an account. And then this will ask me to go check the emails. So this kind of email will pop up. I will copy paste the confirmation code. Click confirm. And now it's setting up my account. Shouldn't take long, and I'm in my nRF cloud. And now I want to use the location services from nRF cloud, and for this demo this is all we use. So I need the authentication token from here. So go into the Teams page. So on the top right corner there's a menu. Click your team, and for the free tier account you have 30 days time to evaluate. So get a new evaluation token from here. So click generate, then click OK, and I will get the token which I copy. Now let's go to the Coiote, and I'm on the main page. So click integration from the left menu, location services, there's a section nRF cloud, so click connect and paste your token here, nRF cloud authentication token, and click save. Now this should be everything needed to get these two services integrated. So I'm now ready to add my first device into this. So let's go to the VS Code. So I will build the application first. So for this demo, I'm using the nRF 9160 LwM2M client sample. So you have your nRF SDK clone. So from the nRF samples 9160 and LwM2M client, right click, add folder as an application, and now on the this nRF Connect plugin view, you will see the application LwM2M client and create the build configuration. So I'm using the default project config, but for the AVSystem, I need to add the overlay AVSystem fragment. Click OK and click build. Okay, now the application have built itself, and I can see that my device is already connected. So I will flash the device. I will click erase and flash just to make sure that there's no settings remaining on the device. And in the terminal, I will open serial terminal to see. Okay, now the application is starting. I haven't added the device yet, but I built the application first just to get the, you need this email code. There are other ways to get, but this is the easiest one. Build the application and start, and you will see what is the email of the device, or the name of the endpoint is based on the email. So let's go into the Coiote side, go add device, and because I'm using the free developer plan, there is no way to use the Bootstrap server, so I add it to management server directly. So device ID must be the same as the URN : email : and the email code, and the key identity the same. You don't necessarily need the friendly name. And the application by default, it uses PSK. And this time I didn't modify any key. So I'm using what the default build time key is. So it's 0001 up to the 0F. You can copy paste this from the kconfig, or you can copy paste this from the documentation. I'll click add device. Then I can check my device and reboot it once more just to get it reconnected. You can see that it claims that it's registered, and there's developer settings now on this, so every time it boots, it is actually overwriting my key into the modem. So that's why there's always the same key. So my device is connected successfully. I click next. And I don't need to set any observation this time, so I click finish, go to device, and it should show me that I'm registered. So now the both clouds are set up and my device is perfectly connected to the AVSystem. So the next part of the demo is that I will show how this integration is now working. So I will show the cell-based location demo. So I will build the same application with the settings that will use the multi-cell location query. So this how it works is that the LwM2M client will start up and it will search for the neighbor LTE cell towers. And after getting registered to the AVSystem, it will update this information into the AVSystem, which will then make the query towards nRF cloud. And when it gets the estimated location back, it will update that and show my location on the map. And so the code is already there in the LwM2M client. So only thing I needed to modify is that the so instead of just building with the AVSystem over, I will add one more overlay here. Overlay assist cell. This will enable the cell-based assistance. And this, let's generate the configuration first, because there's one more thing that I want to modify. Okay, now the configuration have been built. So the thing that I want to modify is that you saw that every time the application start, it will provision keys to the modem, and this is necessary for the first time. It's okay for the development purposes, but I don't want to do it constantly, so I remove the default key. So click the K, once you have the configuration done, click the kconfig, go to application sample and LwM2M object pre-shared key, and just remove this key, click save, close the configuration. Now you can build it. Okay, the application have been now built, so I click flash. Now I go to the serial terminal. We can see that the application is booting up, and every time it gets registered to the server, it will do send operation, and this is actually event that has been triggered there. So I can see my device connected here, so I go to the management page, and I should be able to see my device location now. You can see that there's a circle around it, knowing that this is much larger circle than what it would be with the GPS. And I'm currently inside our office, so I cannot even get the GPS here, but I'm perfectly capable of getting the cell-based location. You can see from the information page that this location is coming from the cellular data, so it's not GPS. So this is all integrated in the LwM2M client sample that we are shipping with the with the nRF Connect SDK. If we recap, all you need to do is to use overlay assist cell, and of course overlay AVSystem, because we are using AVSystem now. they are the only one who have done the integration. Okay, then let's check the second part of the demo. So that would be HCBS through the AVSystem. It works quite similar like the cell-based location, but this time we are only getting assistance data from the cloud, and that will be fed into the GNSS module, and then later on we will get the faster fix time to the GPS. So the building is quite similar, so let's go to the VS Code, and I will remove the existing build configuration. I want to show from the beginning. So let's add the configuration to the board. Same project file for the kconfig fragments. Use the AVSystem as previously. Then we use the assist HCBS, and then we use one more fragment here. We use the queue mode. So reason why I'm doing this is that I want to show something. So in nRF 9160, if you check from the documentation, GPS receiver, it multiplexes the time with the LTE modem. So I need these idle and power saving modes in the LTE modem so that the GPS have some more time to work, and therefore I'm using the queue mode, and that will enable some of the power saving features already. For the demonstration purposes, I want to change a couple of things, so I only click the generate configuration first. Okay, now the configuration have been generated, so I'll go to the kconfig, and same as in the previous, I'll remove the key because I have already provisioned that, but then I want to turn off extra objects that I don't need for this demo, just to save some data as well, and get the much cleaner log output. Then for the power saving or the queue mode optimization, we usually update 8 seconds before the lifetime expires, but for this demo I'm putting that to 200 seconds, so that will leave a bit more. If the lifetime is 300 seconds, that's 100 seconds, and that should be enough time for the GPS to get the fix. And now I built the software. Okay, so software is now built. So before I flash the device, there's one change that I want to do on the Coiote side. So go to your device, and we want to see the location object being updated. So you see that the by default, if there's no updates, it shows all values as a 0, and that's how the device boots up. But I want to see when they change, so I go to this object instance, set observation. Observations mean that when the device data changes, it should be sending the information to the server. So let's say we want to see not more often than once a minute and at least once an hour. That would be okay. Now let's go to the VS Code and flash the device. And now the device is, I think I should have enough coverage for the sky. So let's see how it booting up. Takes a little bit time to join the LTE network. I think it was around 20 seconds last time. Okay, now I'm connected to the Coiote. We can check that the overview changed, registered. You see that when the device got connected, it's requesting HCPS data, and we started the GNS scan as well. Then after some handshake, we are getting the HCPS data from the server side. There's one more thing that is happening is that now we already know the rough location because we made the HCPS query, which is almost identical to the cell-based location. Now we know that based on the cell information, we are somewhere here, and then the HCPS data have been generated for this array. Location object have not been updated yet, but the subscription or the observation data have been sent to device. So now we are just waiting. So I'm in a queue mode, so I'm seeing these messages like RX window closed. That means that there's no radio or any network communication happening anymore. And now all the radio data is now for the GPS. Then we got some time out of the registration, so there's an update, and now it should be silent for a while, waiting for the fix. Now we got the fix. RX window closed. I'm not sure if this got updated, not yet, so we have to wait for the next update to come. This is the thing on queue mode. It does not wake up every time. So on the next update, I should get the correct location to the server as well. Speeding up the time a little bit. Now we got the registration update done. So let's go to the AVSystem and refresh. Location, not yet. But I can also send the request if the observation data have not been sent yet. Now I got the, you can see that there's new coordinates. Okay, this is how the HCPS is working. It should speed up the time to fix. So this is where we get the data, and it's then written to the module. And then once the radio turns silent for a while, it shouldn't take long for the GNSS module to get the fix. So in this time it was a bit more than 20 seconds.
Okay, great. Thanks for that, Seppo. If you enjoyed the demo, if you want to try it out, feel free to buy an nRF 9160DK and follow the steps at nordicsemi.com/AVSystem. If you enjoyed this webinar, if you want to watch other webinars, feel free to register at nordicsemi.com/webinars. We do also have a lot of on-demand webinar recordings, so just head over to webinars.nordicsemi.com for more information there. So without further ado, let's head on over to the Q&A. Okay, great. Martin, Seppo, do you want to just get started? We have quite a few questions.
Sure. Martin, do you want to start from the first question there?
Sure. So there was a question, could you detail a little bit the bridge to third parties cloud? What kind of bridges do you provide? So at the moment, it's Microsoft Azure and AWS. There's also nRF Cloud, as we have demonstrated just a moment ago. However, so these are, these out-of-the-box one-click integrations. However, Coiote allows you to send your data to any endpoint in any cloud using REST API or Kafka. However, this still requires some effort from you in order to configure it, so it's not as simple as this, nRF Cloud like integration, like Seppo showed a moment ago. Another question, is there end-to-end DTLS security between device and customer cloud, or is the tunnel fractioned into parts? I assume this is this question about bridge to the cloud. So there is a DTLS security context established between a device and the Coiote server at the moment, and at the server there is a termination of the security context, and then a new security context is established between Coiote and the cloud, or the service in the cloud where the data is flowing into. Another question, what is the added value of using the Andrzej lightweight machine-to-machine client versus the Zephyr lightweight machine-to-machine client? So in general, Andrzej supports 1.1 version of lightweight machine-to-machine. There is an experimental limited set of features for 1.2, so it is providing more features. These features are mostly about additional optimizations that enable more energy efficient operations, like support for DTLS connection ID, which lets you avoid unnecessary DTLS handshakes or session resumptions in case, for example, your NAT binding is expired. There are additional mechanisms for data telemetry reporting. There are also additional data encoding schemes that reduce amount of data exchanged with the cloud. Some messaging rules have also been relaxed in lightweight machine-to-machine 1.1 to optimize communication. And additionally, there are also bindings to co-op over TCP and also for non-IP networks. In terms of security features, there are bindings for secure elements, EST, and IoT safe as well. IoT safe is this standard that treats your SIM card as a secure element and can be used for secure storage in your device. Seppo, I think now it's back to you.
Yeah, thank you. So okay, from top. So what are the kconfig fragments, and does this relate to overlay files? So in a Zephyr, there are 3 different overlay files. There are CMake overlays, divide tree overlays, and kconfig overlays. So these overlays that I was using, so they are just kconfig fragments. So this is just the basically the same thing, but relates to kconfig. Yeah. Then next question, what is the difference between flash and erase and flash in the nRF Connect SDK? The VS Code. So flash command only erases that the area where the application is stored, but the flash is also used to hold the photo update image and the permanent storage for the settings backend in the Zephyr. So if you want to get rid of all those, you want to use the erase and flash, and that will actually erase the whole chip, whole flash area of the chip. Okay, next question was a simple. Where can I find the IMEI code needed during the demo? So of course, I was using the serial output, but you can see that that's on the sticker on the bottom of the board as well. Then there was a question regarding accuracy of the single cell, multi-cell, and GPS. So this is something that depends on the environment very much. So I would say that roughly, let's say 1 kilometer for single cell, or 300 meters on multi-cell, or like 10 meters on a GPS when the conditions are good. What is the next question there? Which private key or certificate is used for the TLS? So in nRF 9160, all those security keys or credentials are provisioned to the modem. So we use PSK that is provisioned by the application, but we could also use, we could provision those beforehand using AT commands. So before flashing the final application. Then there was question whether our embedded stack is supporting ESD. I'm not sure if this is referring to ANSI or the Zephyr stack. So at least the Zephyr LwM2M stack doesn't support ESD yet. Also, the nRF 9160 has limitations on certificates when we use TTLS, so on top of UDP. So we only use the PSK on the TTLS, so we can enroll the new keys during the bootstrap. So at least that Zephyr stack doesn't support ESD, but on the ANSI there are ESD support, of course. Yeah, nRF 9160 has still a couple of limitations.
Seppo, do you want to maybe go through one more question? Before we're a few minutes over, so, or do you want to go through the rest of the last three?
Yeah. Okay. So I'll go those quickly. So
yeah.
What is the question is, what is the bootstrap server you mentioned? So this is LwM2M specific thing. So there is a bootstrap server that can basically provision a new keys or the server endpoint address. That is part of the specification. Then next question, what is the reason for using PSK instead of X509? So this is what I was referring earlier, that there's a limitation on nRF 9160 modem, so that the certificates currently work only on TLS. So on the TTLS, we are still limited to PSK. Last question was the in the GPS demo, you enable PSM. Is this a key requirement for getting the GPS to work? Is it because of power reason? So no, it's not the power reason. So the GNSS module can only listen then when the LTE radio is not sending. So anytime, any silent time that the LTE is using, it's okay. So I'm turning on the PSM just to get the more silent time there. So.
Okay, great. I just have two quick questions before we wrap up. Do I need to contact Nordic and AVSystem to try? No, so it's all self-service. All you need is a 91DK, and then you can start the free trial online. So you just need to basically follow what Seppo did. And last question, commercially, how can I have both AVSystem Cloud Services and Nordic nRF Cloud Location Services? So they are two services, and even though there's an out-of-the-box integration, customers are required to engage commercially with both companies separately. But we both have, so both AVSystem and Nordic has self-service free trial for developers for 10 devices. Marcin, Seppo, do you have any final comments before I close it?
No, I think that was all was covered.
Okay, good. So yeah, I just suggest, buy an nRF 9160 DK and try it out. I think that's the best way to get started. And like I said, if you want to sign up for more Nordic webinars, feel free to do that at nordicsemi.com/webinars. So thank you, Marcin. Thank you, Seppo. And thank you all for joining this session. Okay, great. Let's get started. Yeah, so Seppo, do you want to start off with a few questions?
Yeah, sure. I guess I'll start here. So first question was that which extension of the VS Code is used to build the nRF 9160 application? So Nordic has published this extension called nRF Connect for VS Code. So that is a plugin that will basically help you to build the Zephyr applications. It doesn't do any magic itself. It uses the West normally like Zephyr would use. Second question was that do you use DTLS connection resumption feature? If yes, in which format are credentials saved on the device? In file system, or are they accessible? So in a 9160 modem, the TLS stack is inside the modem. So yes, we do use the DTLS connection resumption, but the credentials are not accessible from the application side. So we can provision keys to the modem, but those credentials regarding the connection resumption or session cache, those are not accessible. And I guess Marcin, sorry, yeah, do you want to jump into next questions?
Yes, sure. So a question, talking about optimizing Andrzej for the embedded world, what's the smallest reachable footprint? So we're talking here about the Zephyr and Nordic environment. So the raw Andrzej is 130 kilobyte flash and 16 kilobyte RAM. However, if you want to integrate it with the whole client application with embed TLS, FOTA, secure elements, the fully functional client is 330 kilobyte flash and 60 kilobyte RAM. The second question, when it comes to using Andrzej with a cellular LP1 radio access technology, the common layers are IP and UDP or TCP. Still, NB-IoT and LTE-M do not provide reliable BSD sockets, unstable from time to time. How did you manage to stack reliably Andrzej on top of those RATs, radio access technologies? So lightweight machine-to-machine standard is focused on providing high reliability connectivity, even under very challenging circumstances. So features like Q mode make it possible to stop transfer until the connection becomes stable again. In addition, Andrzej also provides an API that allows user to give more context to the library about the transport layer and its availability. So you can think about it as in Google Doc, there is this recent feature of entering offline and online mode, so that you may keep editing your Google document when you are not connected to the cloud. So something similar is available as part of Andrzej. And the idea is that you are not wasting your resources on trying to send data when you know that the link is not available. And in addition, Andrzej provides also data persistence unit where the data are stored reliable on device in case of lack of cloud connectivity, and when the connectivity will be restored, the data that were supposed to be sent will be then cached and then sent later. And next question, how fast will work next path? Device, AVSystem, AWS IoT app. So I assume the question is about how quickly will you be able to push your data to AWS cloud from the IoT device using AVSystem. So at the moment, Coiote provides connector both Azure and AWS IoT services. And integration with Azure is a one-click effort. You just need to, provide this connection blob, and everything is working. However, for AWS, there is still a little effort needed, and this is mostly on AVSystem side, on our support engineers to help you configure it for you. And at the moment, we are working on making this integration as easy as it is for Microsoft Azure. I think these are all questions for us, for AVSystem.
Yeah, I can go through. I have 2 more questions quickly, and then we can wrap it up. Do I need to contact Nordic and AVSystem to try? No, it is all self-service. So basically all you need is an nRF 9160 DK, and then the free trial is available online. So all you need to do is register on the AVSystem and the nRF Cloud web pages like Seppo showed to try it out. And another question, commercially, how can I have both AVSystem Cloud services and Nordic nRF Cloud location services? So they are 2 services, and even though we do provide a sort of a seamless unboxing, you will need to sign a commercial contract with both companies. But both companies do have a self-service trial so a free trial for up to 10 devices. Apart from that, like I said, if you enjoyed this webinar, if you want to watch other webinars in the future, if you want to watch some on-demand webinars, just head over to webinars.nordicsemi.com for more information there. Seppo, Marcin, do you have any final comments?
No, thanks for watching.
Likewise. It was a pleasure.
Okay, great. Thank you so much, Seppo and Marcin, and thank you all for joining and watching the webinar. Have a nice rest of the day or a nice evening. Bye.
Thanks, everybody. Bye.